So, hi guys, welcome back to the second lecture on artificial intelligence series. I am Nitish and I'll be having today the difference between artificial intelligence, machine learning, and deep learning. Every people these days think similar, like these topics like machine learning, AI, and deep learning, they are same thing. No, not at all. These are not same thing. We'll be discussing what is the difference. We'll take analogy and we'll have use cases for machine learning, and we'll discuss in detail what is deep learning and why it is used, right? So let's go ahead with our discussion today. Okay, guys, see this one. You can see artificial intelligence is a big umbrella under which machine learning lies and under which deep learning is a part, right? So, what is artificial intelligence? Is a technique which enables machines to mimic human behavior, right? What does this mean? We'll discuss in the second slide or in the next slide actually. So machine learning, it is subset of artificial intelligence which use statistical model. Actually, this machine learning is the technique which enables this artificial intelligence, right? Without these techniques, without this algorithm in machine learning, we cannot expect artificial intelligence, right? And deep learning is further subset of machine learning which have complex calculations, like it behaves like human brain, like human brain learns or thinks and predicts. In the same way, deep learning makes neural networks like artificial neurons to make calculations and learn like human beings, right? So we'll be discussing use cases and how it is being done in the further slides, right? So let's take analogy for artificial intelligence. The first one, right? Artificial intelligence, you see. This is a McDonald's shop. Here you can see people distributing, taking the orders from customers and then delivering it to the people, right? So what happens? These are done by the people, but machine has the capability to mimic this behavior of these people, like clerks. This behavior of clerks can be mimicked using machine. Instead of people over here, we can keep machines and they will take the orders and they will deliver the products, right? So now machine will be able to mimic the behavior of humans, and that is what artificial intelligence means. Now you see this one, ATM. So in ATM we have present day guards, but in you see in developed countries where artificial intelligence so much developed, there you will find there is no guards at ATM. Rather, it has been replaced by machines which has object detection models, which can easily detect a threat or a normal people, right? And in that way, it is replacing the human being. So machine is acting like a guard, and that is what mimicking the behavior of human being. That is what I meant in the last slide, the definition of artificial intelligence. Now it's a relative concept actually. Back in 1950s, when this AI concept first came up, it was a big blow to everyone. Like Deep Blue. This is a robotic chess champion in 1997. Everybody was like, wow, what is such a thing, right? And it used actually tree search algorithm to evaluate millions of moves at each steps. You can see here in this one, this is an example of how the queen problem, which uses backward and back propagation and all steps backtracking actually to have the predict the next move. So that was what artificial intelligence. But nowadays you can find in our Netflix, our YouTube, or whenever you search something on Amazon, you get advertisements the moment after that, right? How does this happen? It is all AI actually. So AI also, that is the technique which enables the human behavior, human mimic the human intelligence actually, right? We'll see next, that is machine learning. Now, one of the prediction which is being done these days that AI will eat most of the job. Yeah, you can say most of the time that it will be happening in the days to come because it is replacing actually humans. So of course it will be eaten by the it will eat the jobs of the people actually, right? You see this one, this. This is a computer system and this is a human being. So now human being is playing with the computer, and even computers have become so advanced these days. Now AI has become so much advanced and so much useful in our life, we cannot imagine even, right? Let's come on to machine learning. So machine learning consists of algorithms which enables the artificial intelligence AI. So what are the algorithms contained in it? There is supervised algorithm. Supervised algorithm, in the last slide, go back if you have not watched, go back and watch that. You will be having a last video lecture. You will be learning about supervised and unsupervised. I'll explain what are the algorithms of unsupervised learning, like K means, K shift, K models, then feature selection, a local discriminant analysis, and all these are the unsupervised algorithms which are used. And then we have supervised learnings. This consists of regression, decision tree, linear regression, logistic regression, naive bayes, support vector machines, and k-nearest neighbors. We'll be going through these all most probably in the coming lectures. Supervised learning. For unsupervised learning, we'll have to learn more towards this as of now. Right. You can see what is this decision tree. Decision tree actually it works on if else. If this, then do this. If yes, then do this. Right. So that is what it is. Next algorithm which comes in machine learning is the linear regression. You can see height in centimeter. These are the dots. Like this is the height, then this is the weight. This is the height, then this is the weight. These are the data set. Now we'll apply this algorithm, machine learning algorithm called linear regression is there inside this library of sklearn. You can go and see it. We'll see in the use case also. So what it does that it finds a relation between these variables, and the relation it has found out is weight equals to h minus 100. Means whenever we'll give height, suppose this height I gave you, you will find out the weight using this formula which it has been found by machine learning. This relation actually. Now coming on to deep learning. So deep learning is further subset of ML that helps in mimicking the human brain type behavior. In the human brains, what happens? There are neural nets and neural networks, that is artificial perceptrons. So, human brain we have connections. Like one of the neuron passes the information to next, and then in the series continues till the like suppose we pass some information from our eyes that goes using neurons to our brains, and that goes in much defined way using these computation. Like these all will be combined to this one, then further these all will be combined to this one. So these all combinations will have weights and biases. These combinations and permutations involve lot many millions of calculation and millions of ways. So once you have millions of ways, you can well evaluate like which one is correct way and which one is wrong. Like we go forward direction, we come back and we see what is the error occurred, and then we go back and we change our weights, and we again calculate the permutations and combinations, and further we have these actual outputs. So that is deep neural network, means using layers of neural network, and more layers we use, more defined our algorithm is. And then we have convolutional neural network, which is used for feature extraction, like image classification. Neural network is used when we have further more classification, like we want more defined classification, we want feature extraction, automatic feature extractions, right? We don't have to, suppose in machine learning what used to happen, we had to separate the features ourselves manually. But in deep learning, what happens? This feature selection and all this, it is automatically done by neural networks and convolutional neural networks using combinations and permutations. And in convolution neural network, it becomes more better. In recurrent neural network, it is used for sequence of events, language models, and time series and all. Right? These days, speech recognition, then we have voice recognition, speech recognition, then we have ads prediction and all. These all things are being able to be done by this neural network. You see in daily life, these all things are used. Now, one question comes here is why this deep neural network has gone so ahead. Like in 1997, there was a time that there was AI winter. Means nobody thought like AI will be booming. No, people just ignored AI actually, right? But nowadays it is booming because of three things actually. First is amount of data which has increased due to digitalization. Nowadays data is being generated at very far ahead. So what happens like if we apply machine learning algorithms, which we saw in the previous slides, with the increase of data, this becomes stagnant. This does not improves the performance. But when we use deep learning, it improves with performance, right? With more and more data, performance increases. That is one reason. Second reason is our like deep learning uses computation power, like CPU and GPUs. So increase of the growth of CPU and GPUs have increased tremendously actually, and that has propagated, that has accelerated the growth of these deep learning algorithms. And the third thing is the performance actually. Whenever we use images and videos for our classification, the deep learning performs much and far better than machine learning algorithms, and that has accelerated its progress these days, right? Now let's go ahead. In the next slide we'll see a deep neural network working actually. What happens? Deep neural network means deep. Deep means what? Hierarchical features. Like one of the features we take. Suppose this is an image. In this image we have faces. You see these faces, we extract the features out of it, like eyes, nose and ears. We further combine these together to form faces. So when we do classification, what happens? Like cat is there, right? So we can identify if it has fur, it has tails and all, then we can tell that it is cat. Similarly, if we have eyes, nose, ears and all, then we can say that yeah, it's a face. So these extraction has to be done, and that is being done by convolutional neural network, right? You see, in the first layer we take pixels, and each pixel is considered as one of the features, and these features is combined together to produce more pixels, and these further combine together to form more features, and in this way we have output layer. Finally we have output. So once we have output, we compare it with actual output that is predicted on actual output. We go back, we back propagate, and we change our weights and biases. Here we have weights and biases, and we predict again, and we keep on doing this, repeat this until we find like yeah, we have come to a conclusion. Yeah, we are most similar to the actual model. Now we'll see what is difference between deep learning and machine learning in terms of certain factors like data requirement. So of course you saw earlier also it requires huge amount of data, but machine learning can train on lesser amount of data also. Accuracy, yes, high accuracy, but it gives lesser accuracy. Training time, you see, takes longer time to train, it takes less time to train. Requires GPU to train properly, it trains on CPU as well. So that is what computation power I was talking about. Hyperparameter tuning can be tuned in various different ways. Limited tuning capabilities. What is this hyperparameter? We'll see in the next lectures coming on, right? So now next we'll go on to what I was telling is use case of machine learning. I was just telling you there is one sklearn library. So this is one regression test actually. We'll do regression analysis, like how regression happens, what is coefficient, what is intercept. So you saw in the one of the slides, you saw one of the graph was there like this, right? That was linear regression model. So we have data set X, right? You see this one X. So in this X, we have one of the vector 1, 2, 3, 4, 5. In Y, vector is 4, 8, 12. Can you find the relation, guys? Yes, you can of course find. You see 1 into 4, 2 into 4, 3 into 4. Yes, that is the relation actually. Once we multiply this vector by 4, we'll get this vector. But how our brain has found out using our like training and all whatever learns as till now. But how machine will do this? So what we'll do, we'll take this, reshape this first, right? And we'll take one model. Model will be linear regression, which we import from sklearn library, right? So we have got this model here. Now model dot fit x and y. We'll apply these vectors here. So now what it will do, it will apply some weight. Suppose arbitrary it will apply 6. So 1 into 6, 6. So there is error of 2. So 2 into 6, that is 12. That is error of 4. It will subtract this error and go back and change that weight. So weight, now they'll give weight as 3. So 3, 1 into 3, again there is some error. 2 into 3, again there is error. It will keep on changing the weight. When it will come to 2, it will see, yeah, it's matching, the error is 0. And it will see, yes, 2 is the coefficient which I need. It means the relation is 2x, right? So 2x is the relation that will come to a conclusion after repeating a lot of times, right? So that is what we'll see. You see, this is the output actually. We'll run this once to see you. We can print this coefficient and then intercept, like we have intercepts in, you must be knowing, you must read, you must have read in mathematics. You see this one. So we have m1, that is slope is 4, that is relation between this is 4 times 4x actually, sorry that I told 2x, right? And root mean is square, that is actually it is calculating error, like how much error it is coming. Of course it is error less, 1 minus you have to do. Actually this is wrong, it should be 1 minus this should be 1 minus this, right? So now you run, right? You see, is it internet? Okay, yes, we'll see, we'll connect it to internet, right? Okay, okay guys, so now it is connected to internet. You can see, I'll run this. So now model is running. You will see this squared error. So error must not be 1 actually, it will be always 0, right? Error is, sorry guys, it takes time. So I'll run this again because I have something. So error is now 0. You can see when relation is here. See, intercept is 0. In case if it is required intercept, we'll have another relation. In that case, intercept will be required, and that way it will find out intercept also. It is not that it will always found the slope only, right? That's all, guys. That's all for today. Thank you very much for your time. In the next series, we'll be coming up with further more interesting videos. That's all. Thank you very much.